So here's limits as x goes to infinity. So what we're gonna do here, we're gonna look for all the x's and find the x with the highest exponent. And what you should be doing with that is we're gonna divide everything by x to the 6. So we rewrite this as limit as x goes to negative infinity of 3x to the 6. We're going to divide that by x to the 6 minus 7x to the 5 divided by x to the 6 plus x divided by x to the 6. And we do the same thing to the bottom. So we have 5x to the 6 divided by x to the 6 plus 4x to the 5 divided by x to the 6 plus or minus 3 over x to the 6. And now what we have the limit as x goes to negative infinity of the x to the 6's here will cancel, so we end up with 3. Here the x to the 5 goes and x to the 6 becomes x to the 1, just reducing, so 7 over x. And plus 1 over x to the 5 as we reduce this x goes to 1 and this x to the 6 goes to x to the 5. And here on the bottom we end up with 5 plus 4 over x minus 3 over x to the 6. Yeah. Now, this will give you, if we make this really small negative number and you divide by a big number. So what we do here, if we make x really big, like negative infinity, when you divide, this number here will go very close to 0. And also here, negative infinity to the power of 5 is going to be even bigger. And 1 divided by a huge number, or maybe I should say very huge negative number, you'll end up with 0. So all of these here, they become zeros. Are you dividing by a big negative number? And your final answer will be just 3 over 5. Okay. So here are 2 questions that they want us to do the derivative. The first one is with dy dx, and the other one also with dy dx. Here, though, in the second one here, it's going to be implicit differentiation. So dy dx or y prime here would equal the derivative of e to the power of anything is just going to be itself e to the power of cos x squared. And the power rule now tells me to take the derivative of the cos x squared. So I do the cos first. So it's going to be, so cos will be negative sine x squared. And then I go to the x squared and take the derivative of that as well, 2x. And therefore, the derivative of this is going to be 2x. And I'm going to just throw the negative in front of the sign right there, and then sine squared x e to the power of cos x squared. So just make sure you follow the chain rule and know your rules for e to the power of f of x. If you want to take the derivative of that, it's e to the power of f of x times f prime of x. And that's the rule that we followed. And the derivative of cos is negative sine So it's going to be a negative sine x squared. And then you have to go to the x squared and take the derivative of that, and that gives you 2x. So now we move on to this, and this one here is not as simple as this. Maybe I'm thinking this is simple, but this one is a bit more complicated because you're taking the derivative with the respect to x, and you have y's all over the place. So the first thing you got to take the derivative of ln x. So that's going to be 1 over x plus y, because the derivative of ln of y equals ln f of x, then y prime is 1 over f of x times f prime of x. Yeah. So therefore now we got to multiply by the derivative of this. That's because that's f of x right there. And it's going to be 1 plus the derivative of y is 1, but then dy dx or y prime. We'll just use y prime. Equals. Now, here we're going to have the product rule here for x, y. So it's going to be the derivative of x is 1 times y is going to be y. And then the derivative of y and is going to be plus. And the derivative of y is going to be 1 y prime times this x. Now we go to this. The derivative of 3y is 3y squared. Sorry, the derivative of y cubed is 3y squared times dy dx or y prime. Now at this stage, we gotta solve for y prime. And the way we're gonna do this is, I think the first thing I'm gonna do is cross multiply the x plus y to all of this equation right here. So 1 plus y prime equals, and I'm gonna multiply that and all of this. So it's gonna be y x plus y plus y prime x times x plus y minus 3y squared y prime, that also times x plus y. Now what I'm gonna do, I'm gonna bring everything that has a y prime to one side and everything that doesn't have a y prime to the other side. So what I'm gonna do here, I'm gonna go 1 minus y times x plus y equals the y prime x that we have already there, x plus y, minus the 3y squared y prime x plus y minus y prime. Now what I did, I brought this y prime this way, and I brought the y x plus y that doesn't have y prime to this side. And the reason I did that because just it's easier. This is a lot of stuff to bring it over. So I brought the y prime this way, and I brought this to that other side. Now I'm gonna take out y prime as the greatest common factor from here. So y prime is the greatest common factor, and I'm gonna get x times x plus y minus 3y squared x plus y minus 1. And I still have this 1 minus y x plus y on the left side there. And now we're just gonna divide everything by this. So just the lack of space, I'm gonna write y prime. So when you divide both sides by this right there, then what you end up with, the y prime on the right side equals, and just switch it to the left side, 1 minus, it's gonna distribute the y into the x there, so minus xy plus y squared all over. I'm gonna start distributing those in here, so it's gonna be x squared plus xy minus 3xy squared minus 3y cubed minus 1. And you know what? This is what this question looks like, and that's what y prime is. Pretty involved, so lots of x's and y's all over the place. So, and this is it. This is the limit as x goes to infinity for the first question, and then just taking the derivative of some of the more complicated equations. Okay, thank you for watching again. Till next time, bye-bye.